Hey fans, welcome to the channel. We are looking at Capture Recapture. Make sure you watch the pre-skills video looking at cross multiplication. You're going to need to know that in order to do this topic. In this video, we're going to be looking at what Capture Recapture is, some examples of how to do it, and then some practice questions. So imagine if you are trying to estimate the population size of the fish, a number of fish in a lake. So it doesn't make practical sense or economical sense, or perhaps even it might not be possible to capture every single fish in a giant lake. So we're going to have to estimate the population, and this is where Capture Recapture comes in. It is something that biologists use and other scientists as well, and it helps us estimate. I'm going to highlight that word, it's very important. It doesn't give us an exact number, but it's an estimate of the population size. And population is also an important word. Population is like the total number of something. So we're going to look at what this method looks like. So let's say you are a scientist trying to figure out how many tigers live in the jungle. Obviously you can't capture every single one, and they might be quite difficult to capture because they might be quite elusive. So we're going to use Capture Recapture. First thing you might do is you are going to capture some tigers. The number of tigers you capture will depend on individual situations, but in this case, let's assume you've captured 3 of them. What you're then going to do is mark them. It could be with some type of tag. You might use a non-toxic spray or something, so you know that you have seen this tiger. In this case, in this slide, we're just going to turn them orange. We're going to say that we've got these orange tigers that have some type of mark in them. Sometimes you put GPS trackers on them, for example. And then you release them back. So you've now captured 3 of them. You release them back into the population, and they get mixed up. And then sometime later, which might be, for example, a few days, a few months, depending again on what the situation is, you then capture a second set of tigers. So this is like a recapture. Now, when you do that, you may not get the original 3 tigers that you captured. You might get maybe 1 or 2 of them, but in this case, we're going to assume that we've captured 3, and 1 of them has been marked. So what we have here is 1 out of 3 being marked, and we're going to look at the ratio of this fraction to the original fraction. The original fraction was, if we go back, the original fraction was 3 out of, well, that's out of the whole population, and we don't know that number, so we're just going to call it n. And essentially what you're doing is you're just equating these 2 fractions, and you're saying the proportion is going to be the same. So you can say 1/3 is equal to 3 over n. Now, if you know how to cross multiply, you can just use that to work n out. But in this case, the numbers are so easy that you could actually just use equivalent fractions and say, well, if that's times 3, this is also going to be times 3. Therefore, n is equal to 9. And that's the total population of tigers. Now, the numbers in this example are very, very straightforward. Realistically, picking 9 tigers, picking 3 out, having a population of 9 might be a bit too small, but a scientist might decide whether that's suitable or not. But this is basically the big idea. And we're going to look at this in a bit more detail. So with these equivalent fractions, one thing you could do is scaling, which is what I did in this example here. Another thing we can do is just cross multiply. So 1 times n equals 3 times 3. And you're going to see me using that a bit more with some of the upcoming questions. Now, there's a few things that we need to consider from this method as to why it's suitable, what's the weaknesses and what's the strengths of this method, because usually part B of a question might ask you something like that. So for example, how would the answer be affected if some of the tigers have moved away? So for example, populations might migrate. If you're looking, for example, at birds, some birds fly halfway across the world. They have completely different habitats at different times. So has the population emigrated or migrated. Another thing might be, how would the answer be affected if tigers were repopulating? There are certain species that are very quick to repopulate. There are certain species that are very slow. So depending on the birth rate of the tigers. And then another aspect to consider is, how would this answer be affected if some of the tags fell off or were not visible? That's again something that might affect your data. So these things you can mention in terms of strengths or weaknesses and how that might affect the final answer. Maybe it might result in you overestimating or underestimating a population. Now, I don't like presenting this topic as a formula because it's just something that you can intuitively work out. But just for completeness sake, I will put this up here. Essentially, what you're going to be doing is the total marked items over the total population. Usually the question, this is your unknown, the total population, so that's what you're trying to work out. So that's usually n over the second sample, which is marked out of the total sample. So that's what we were actually doing with the previous question, and actually what we're going to do with all of the questions here. Pause the video and have a go with this, and then I'm going to gradually stop showing you this formula because it's something that you should intuitively work out. So have a go. Okay, so I'm now going to show you how to work this out. So first of all, we can see that he collects 5 and marks them and puts them back. So it's going to be 5 out of the whole population, which we don't know. So we're just going to call it 5 out of n. And then a few days later, he collects 10 and 2 of them are marked. So it's 2 out of 10 which are marked. And essentially, we're just going to solve this by cross multiplying. 5 times 10 equals 2 times n. Once you do the cross multiplication here, which I'll just write here, so 5 times 10 is 50 equals 2n. So n is going to be 25. So that is the total population. And this is an estimated total population. So n is approximately 25. Now state some assumptions that must be made for the estimate to be as accurate as possible. So there's a few things that we need to be mindful of. For example, things I mentioned just in the previous slide. We need to assume that the population is stable, that the population is not migrated, or the sample size is adequate. Have we collected enough snails or not? Here's another question for you to try. Pause the video and have a go, and then we're going to do one more. Okay, so we can see that John catches 20 out of a population of n, and then from the sample, 4 out of 170 are marked. So we're going to say 4 out of 170 is equal to 20 over n. We can then cross multiply this. So 4n equals 170 times 20, which is 3,400. And then we can divide both sides by 4, and that gives us 850. So that's an estimate for the total number of rabbits. Have a go with this final example here. Okay, so I'm going to show the answer here. So what you should get is 150. The rest of these examples are optional because this kind of covers most of the topic. However, the next video, or one of the videos in the playlist coming up, is quite important because it's looking at all of the questions, for example, in a bit more depth. But this is the main idea. I hope that was useful. Smash the like button and hit subscribe.